question number 10, we are asked to balance this chemical formula. So first we count for what types of elements are in this chemical equation. Notice we have iron, oxygen, carbon, and please note that we actually have oxygen again. So we have oxygen in two places on the reactant side. Next, we'll take an inventory of how many of each kind of atom we have. So we have 2 irons, we have 3 oxygens in the iron oxide, plus we have 1 oxygen in the carbon monoxide, and we have 1 carbon. And on the product side, we have 1 iron, 1 carbon, and 2 oxygens. Now notice that this is a multiple choice question. And after practicing this, I found this equation very difficult to balance. So I found it easiest to use the answer choices and guess and check for balancing. So it asks, when correctly balanced to the smallest whole number coefficient, what is the coefficient on the carbon monoxide? Now, if the coefficient on the carbon monoxide was 1, then we would be out of balance, because that basically means not adding a coefficient. And we see that without a coefficient, our oxygens are imbalanced. So then if we go and we try to add a coefficient of 2, and we see the consequence of balancing. If our coefficient was 2 here, we would have 2 carbons, and we would have 3 plus 2 oxygens, which is a total of 5, and 2 irons on the reactant side. Now we know that this is not a possible coefficient, because there is no way to balance the oxygens on the product side, because the oxygens here are O2, they're an even number, and there is no number to multiply this by to get 5. So we know that choice number 1 and choice number 2 are not good choices. Now let's look again and try choice 3. Now if we have the coefficient of 3 here, what that will do is that will change our total oxygens to 3 and 3, which is 6. And if we were to balance from there, we also will change our carbons to 3. So in order to balance on the product side, if I added a 3 in front of the carbon dioxide, that would create 3 carbons and 3 times 2, or 6 oxygens. Now the only thing that is out of balance is the iron. I have 2 irons on the reactant side, so I'll place a 2 on the product side to balance my iron. So we see that 3 here is the best choice. Question 11 is similar to question 10 in that it's a balancing question. So the first thing you'll want to do is take an inventory of the atoms. We have magnesium, chlorine, and oxygen present on both sides. Initially, we have 1 magnesium. Now this chlorate ion is present in parentheses because it has a number distributed to it, this 2. So that means that there are actually 2 chlorines and 2 times 3, or 6 oxygens on the reactant side. Now on the product side, there's 1 magnesium, 2 chlorines, and 2 oxygens. So we can see that what is not currently in balance are our oxygens. So to balance the oxygens, we have to look and find the least common multiple between 6 and 2, which is 6. So to create a 6 here, we're going to multiply the 2 times 3. So if I add the coefficient of 3 here, that creates 6 oxygens. All my other elements are balanced, so there's nothing else for me to do. So again, 3 is the best choice. In question 12, we have nickel 2 bromide. Nickel has the symbol Ni, and its oxidation state is given in parentheses here, +2. Bromide is bromine, and on our reference table, the first negative oxidation state of bromine is -1. When elements form compounds, they cross their oxidation states, so they'll have a net charge of 0. So when I cross my oxidation states, I will have 1 nickel and 2 bromines. Again, the reason they do this is so that their net charge is 0. So here, notice that I have 1 atom with a +2 charge, and then I have 2 atoms with a -1 charge. If I multiply the absolute values of what's in a box, 1 times 2 is 2, that equals what's in the next box, or 2 times 1. So here, the correct formula is going to be the choice 4. Question 13 is a percent by mass composition question where we're looking for calcium in calcium sulfate. That means that we have to find the mass of all the calcium as compared to the entire compound. According to our reference table, calcium has the mass of 40.1. And calcium sulfate's mass would be 40.1 plus 32.1 for the sulfur plus 4 times 16 for the oxygen. In my calculator, that works out to 29%. Question number 14 asks us, what is the percent by mass of oxygen in sulfuric acid? They give us the formula mass. The formula mass, or the gram formula mass, is the mass of the entire formula. So we know that our total mass is 98, and now we only have to find the mass of the oxygen. But there are 4 oxygens, so that's going to be 4 times the mass of oxygen, which is 16. And of course, we'll multiply this all by 100. Simply put this in your calculator. Your calculator will inform you that this is 65%. Question number 15 asks us to write the IUPAC name of N2O5. N2O5 is a covalent compound because both nitrogen and oxygen are nonmetals. Recall that nonmetals are located to the right of the staircase on the periodic table. In nonmetals, we use Greek prefixes before element names in order to name this. So since there are 2 nitrogens, this would be called dinitrogen. And there are 5 oxygens, so it would be called penta, and all chemical compounds end in IDE, so it would be pentaoxide or pentoxide. To find the percent by mass of oxygen in nitrogen dioxide, what you'll have to do is find the mass of part, which is oxygen, divided by the mass of nitrogen dioxide times 100. So this would equal 2 times 16 over 14 plus 2 times 16. Of course, we'll multiply this times 100. Question number 17 asks us to classify a reaction. Now in question number 17, we begin with 1 reactant. We end up with 2 products. So this is decomposition. And the second portion of the question asks, how does the balanced chemical equation show the law of conservation of mass? Well, we have the same number and types of atoms on both sides, so matter is not created or destroyed. We have 4 hydrogens and 2 oxygens on the reactant side, and 4 hydrogens and 2 oxygens on the product side. This concludes the mole and stoichiometry review.